So today we're going to be introducing sine, cosine, and tangent. These are the three basic trig functions of which most other identities, especially any other trig identities, are built upon. The core values being sines and cosines. This is a triangular relationship that we're going to be representing in a slightly different way coming up. But in the beginning, really what we're doing is using tried and true geometry. What is the sine, cosine, and tangent? Typically, these are set up in long chains where you're going to have to find one value which leads you to another triangle, which leads you to a third, fourth, fifth, sixth, and seventh. But the core value is going to be the same. The sine of any angle is going to be the opposite over the hypotenuse. The cosine of any angle is going to be the adjacent over the hypotenuse. And the tangent of any angle is going to be the opposite over the adjacent. Another way to write tangent is going to be the sine over the cosine, but you're going to see if I put sine divided by cosine, the hypotenuses are going to cancel out, and I'm left with opposite over adjacent anyways. So let's go ahead and jump in. We want to solve for the missing sides, and then we're going to check using the Pythagorean theorem. So let's set up our sine, cosine, and tangent and see which ones are going to help us out. So if I have, let's do sine in red. No, we're going to check with red. We're going to do sine in blue. So if the sine of an angle is going to be the opposite over the hypotenuse, the sine of 67 degrees is going to be the opposite of that angle, which is going to be B, over the hypotenuse, which is C. Here we have two unknowns. That's not really going to be too helpful. So let's try the cosine. The cosine of any angle is going to be the adjacent over the hypotenuse. So the cosine of 67 degrees is going to be the adjacent, which is 14, over the hypotenuse, which is C. That has one unknown. I can go ahead and I can solve for C. So with two steps, I'm going to say C times the cosine of 67 degrees is equal to 14. Multiplied both sides by C to get it out of the denominator. Then I divide by the cosine of 67. 67 degrees. That's going to give me whatever C is. I'll come back to that here in just a moment. The last one, we're going to check for tangent. So the tangent of any angle is going to be the opposite over the adjacent. So the tangent of 67 degrees is going to be the opposite, which is B, over the adjacent, which is 14. Again, this only has one unknown, so I can use this to solve. So 14 times the tangent of 67 degrees is B. So I can figure out what that is. And so now we figured out that it's going to be the cosine and the tangent that helps us with this one. Let's go ahead and figure out what those values are. I'm going to pop this over here so that we can see. So here I have 14. Actually, before we even do anything, the first thing you always want to check is, are you in the correct? Right now I'm in radians. I want to be in degrees. So I'm going to say 14 divided by the cosine of 67, and our mode is in degrees. And this is going to give us 35.8 right there. So there's my C. It's a length 35.8. Now, when I check it using the Pythagorean theorem, I want to keep that value. So I'm going to store this value as alpha C. So that way if I type in the letter C into my calculator, boom, it comes up. Do the same thing right here. 14 times the tangent of 67, mode is still in degrees, is going to be 32.98, so that's going to be roughly 33.0. Awesome. And I want to store that, so I'm going to store that as alpha B. So my B, if I type in the letter B, will bring up that value. And so when we check our work here, the Pythagorean theorem says a squared plus b squared is equal to c squared. Let's take a look and see what we have. So my a squared, we already know, is going to be 14 squared. My b squared is going to be roughly 33 squared. And my c is going to be 35.8 squared. Now here's the deal. If we test this out as it is right now, and I said, what is 14 squared plus 33 squared? I would get one answer. And 35.8 squared, I would get a very similar answer. But that would make it look like this equation is not equal. But that's why we stored the values, so that we can see, did we actually type them in correctly? So what we're going to do is I'm actually going to say, okay, so what is 14 squared plus b squared? And that is going to be 1,283.8, 35.8. Oh, no, not 35.8. And type in alpha c squared. And we notice that they give us the same decimal. The answers are then verified. Perfect. So the process isn't too bad. We're using these three relationships to see which one of those relationships is going to help us out. In this case, sine didn't help us, cosine and tangent did, but that's not always the case depending on where the unknown is. So let's set up our three relationships. So sine of theta is equal to the opposite over the hypotenuse. We know the cosine of theta is equal to the adjacent over the hypotenuse, and the tangent of theta is equal to the opposite over the adjacent. See if you can tell which one's going to help you out. Okay, let's take a look. Let's see, did you say sine was going to help us out? Well, we know the sine of 14 degrees is going to be the opposite, so the leg that is not touching that degree is going to be b over the hypotenuse, which is 40. One unknown. Yes, sine will help us. So 40 sine of 14 degrees is equal to b. We'll figure out what that is here in just a moment. Did you say cosine was going to help us? See, the cosine of 14 degrees is going to be the adjacent, so the leg that is touching the angle and also touching the right angle is going to be the adjacent, is a over 40. This is also going to help us. So 40 cosine of 14 degrees. Awesome. We'll come to that here in a second. And if you tried to pick tangent, no harm. It's just not really going to help us out because the tangent of 14 degrees is going to be the opposite. So the leg not touching it, but also touching the 90 degrees is going to be B. The adjacent, which is the leg touching the angle and also touching the 90 degree, is going to be A. Two unknowns, I can't check that out. So let's go ahead and see what we have. Let's go to this and make sure our mode is in degrees, just as part of habit. Yes, it is. So 40 sine of 14 is going to give us roughly 9.7. And I'm going to store this as my B. So now the B from earlier is overwritten. If I now type B, it's no longer going to be that, what was it, like 32.9? It's going to be my new value because I overwrote the old file. Let's take this. So 40 cosine of 14 degrees is going to give us roughly 38.8. And again, anything that was in the A when I hit store alpha A is going to be overwritten with what I now stored in that variable. Let's go ahead and check it out. So A squared is going to be roughly 38.8. B squared is going to be roughly 9.7. And C squared is going to be 40. Let's list this out. So alpha A squared plus alpha B squared is 1600. 40 squared is 1600. Both our answers check out. So that's going to bring us to the last two questions. What I want you to do is I want you to pause the video. I want you to try out number 5 and number 7. Unpause it when you're done to see how well you did. Okay, so now that you've given this a shot, let's go ahead and try this out. So sine of theta is opposite over hypotenuse. So sine of 47 degrees is 44 over c, one unknown. Now, the c's in the bottom, so be careful. What a lot of people do is they just multiply the 44 over, and they solve for c that way, and they think the c moves up into the top. Just got to be careful. It's a two-step when it's on the bottom. So c times the sine of 47 is 44, and then I divide. So cosine is the adjacent over the hypotenuse. So the cosine of 47 degrees is a over c. Doesn't really help us out there. And the last one, tangent of an angle is going to be the opposite over the adjacent. So the tangent of 47 degrees is going to be the opposite over the adjacent, which is a. Again, I'm going to have to multiply both sides by a to get it out of the denominator. And then divide by that trig function right here in order to solve for what a is. So let's figure out what c and what a are. So always check my mode. My mode is in degrees. I'm doing good. So 44 divided by the sine of 47. It's going to give us c is roughly equal to 60.1. Go ahead and store that in c. For a, I have 44 divided by the tangent of 47, 41.0. I'm going to store that in a so that I can check. So a squared is 41.0 squared plus my b, which is 44, equals c squared, which in this case is 60.1. And I'm going to check the actual values that I have in here. So a squared plus 44 squared is going to be roughly 3619.5. And then c squared is going to be that same decimal place. So both my answers were verified. Not too bad. Let's see how you did on the last one. So sine of theta is equal to opposite over hypotenuse. So the sine of 42 degrees, ooh, I've got the angle up here, so I'm looking down. Instead of from the left for the opposite, which would have been b, now the opposite of this angle is going to be 15, because I go across. So I have 15 over the hypotenuse, which is just the side that's not touching the 90-degree angle. Boom. One unknown, it's the denominator, which means 2 steps. C sine of 42, and C is 15 over the sine of 42. Perfect. For the cosine, we're dealing with adjacent over hypotenuse. Now again, normally I'd be looking at it from the left, so the adjacent would be 15, but I'm not. I'm looking at it from up here. So the leg that's touching me and the 90 degrees is B. And the hypotenuse is C. 2 unknowns doesn't really help us out again. Last thing I'm checking out is my tangent. The tangent of 42 degrees is takes the opposite, which is going to be 15, or the adjacent, which is b. Boom. One unknown, it's in the bottom, which means 2 steps. Awesome. Let's plug it in and see what we get. I'm going to check to make sure I'm in degrees. All good. So 15 divided by the sine of 42 is going to give me roughly 22.4. Store it in my c variable. B is 15 divided by the tangent of 42, which is going to be 16.7. Store that in my b variable. When I check it, my a squared is 15 squared, b squared is roughly 16.7, and c is roughly, we said that was 22. So I'm going to say 15 squared plus b squared is 502.5. And c squared is going to be the same decimal. So boom, we verified it. If you have any questions, go ahead and check out the next video. Otherwise, that is basic introduction to sine, cosine, and tangent.